Good morning, everyone. Welcome to the Q&A session 38 from the playlist of NEET Physics Part 1. And the chapter under consideration is the chapter of work, power, and energy. The topic is the power developed by an engine. And based on this topic, I have taken one question which was asked in the CBSE All India Pre-Medical Test in the year 2010. So, here the question is, an engine is started to pump water through a hose. The water flows through the pipe at the rate of 2 meter per second. The mass per unit length of the water in the pipe is equal to 100 kg per meter. So the power of the engine is. So here we have been given 4 options and we have to find the correct one. So this is an easy question, but it involves the usage of a few basic formulas, and those formulas has to be used in the correct order. So the power of the engine, or we can say the power, is given by F into V, where F is the force and V is the velocity. So here the engine is started to pump the water through a hose, and then the water starts flowing at the rate of 2 meter per second. Now we also know that F is equal to the rate of change of the momentum. So this can also be written as delta P upon delta T. Now at T is equal to 0, the velocity of the water, say V1, is equal to 0. And when the engine is started, then the water flows through the pipe at the rate of 2 meter per second. So we can say that at any moment of time, say at T, the velocity of the water, say V2, is now equal to V, and this is equal to 2 meter per second. So the change in the momentum will be equal to M is the mass of the water, and into V divided by T, because at T is equal to 0, the velocity of the water is equal to 0. So F is equal to mv upon T. So if I substitute this value in this equation, say this is the equation number 1 and say this is the equation number 2. So if I substitute the value of F from this equation number 2 in the equation number 1, I will be getting the value of P as mv square upon T. Now we also know that the mass is equal to density is equal to mass upon volume. So mass is equal to density into volume. So if I take the density as rho and V is the volume, now the volume in this case will be equal to the product of area of cross section into the length of the pipe. So this can also be written as A into L, where L is the length of the pipe. So this value of mass can be substituted in this equation, say equation number 3, and mass is equal to this will be equal to rho into A into L into V square divided by T. So this is the another equation which I have got by substituting the value of mass in this equation number 3. Now here the water is flowing at the rate of 2 meter per second. So L upon T, where here L upon T is also equal to V. See here the velocity has been taken in meter per second and the time is in seconds. So here the value of V will also be equal to L upon T. So L upon T can be substituted as V. So I will be writing this value L upon T as V, and finally I will be getting another equation that P is equal to rho A into L upon T is equal to V, and this is V square, so this will be equal to V cube. So this is another equation which I have got. Now we also know that mass is equal to density into volume. So density has been taken as rho, and volume will be equal to A into L. Or we can simply say that rho into A is equal to M upon L. Rho into A is equal to M upon L, where M is the mass and L is the length. So if I substitute this value of rho into A as M if I substitute the value of rho into A as M upon L, then the value, this equation, this P, this can be written as, simply I will be writing it here now, that P will now be equal to rho A is equal to M by L, so M upon L into V cube. Now M upon L is what? It is the mass per unit length. So here the mass per unit length of the water in the pipe is given as 100 kg per meter. So this is equal to 100, and the V is the velocity of the water which is flowing through the pipe. So this is equal to 2. So 2 cube is equal to 8. So the power developed by the engine will be equal to 800 watts. So the correct option here is D. Now here the most important thing here is that first of all, the first important formula which was utilized was P is equal to F into V. Then we have substituted the value of S as delta P upon delta T. That is, we have substituted the value of F as M into V upon T, because here the change in the momentum is equal to M into V. And because at T is equal to 0, the velocity of the water is 0, and at T is equal to T, at time T, the velocity of the water is equal to, say, V, which is equal to 2 meter per second. So here F is equal to mv divided by T. So that this value was substituted in the equation number 1, and then we have got this equation, and from here I have written this mass in terms of density and volume. So M is equal to, this M is equal to rho into A into L. So from here, this what I have done is I have substituted this value in this equation number 3, and then I have again substituted the value of length upon time as equal to V. So this was an important step, and thereafter we got the equation of P, which was equal to rho into A into V cube, where here rho is the density. And now again we know that the mass is equal to density into volume. So density is equal to, so this volume is equal to area of cross section into the length in this case. So rho into L was is equal to mass divided by length. That is, this is equal to, and this was given in the question as 100 kg per meter. So by substituting this value in this equation, that is P is equal to rho A V Q, we got this equation, which was equal to M into V cube divided by L, and M upon L is equal to 100 and V is equal to 2. So the answer is equal to 800 watt. So thank you very much for joining this session. In the next session, I will be coming up with a different type of problem from the chapter of work, power and energy. And so till then, have a nice day. Bye.